In this lecture, we take one more example on reduction formula based on the cosine function. Question is, if in is equal to integration of cos to the power nx into cos nx under the limit 0 to pi by 2, then prove that in is equal to 1 upon 2 in minus 1, which is equal to pi upon 2 to the power n plus 1. We have given that in is equal to integration of cos to the power nx cos nx under the limit 0 to pi by 2. Let us give it equation number 1. Then we have to prove that in is equal to 1 upon 2 in minus 1, which is equal to pi upon 2 to the power n plus 1. Now from equation number 1, we have in is equal to integration of cos to the power nx n to the power cos to the power nx cos nx dx under the limit 0 to pi by 2. Now we know what is the integration of cos nx, so we can directly use the integration by part by using the formula integration of u v with respect to x is equal to first function u integration of v with respect to x minus integration of derivative of u with respect to x integration of v dx whole integration with respect to x. So now this is our u, cos to the power n x is u, and this is v. So if we apply the formula, first function u is nothing but cos to the power nx. Integration of cos nx is sin nx upon n under the limit 0 to pi by 2 minus this minus derivative of first function cos to the power, what is the derivative of cos to the power nx? It is nothing but n cos to the power n minus 1x, and again derivative of cos x is minus sin x into integration of cos nx is, we have already calculated it, it is sin nx upon n. Now this n and this n will cancel, and this minus sign and minus sign will become plus. So let me write down. Again, we can substitute the upper limit is pi by 2. So cos to the power n pi by 2 sin n pi by 2 upon n. And if you put lower limit 0, cos 0 is 1 and sin 0 is 0. So lower limit is 0 plus cos to the power n minus 1x into sin x sin nx with respect to x under the limit 0 to pi by 2. Now cos pi by 2 is 0. So this part will become 0. Sin n pi by 2 is its value will be either 1 or 0. Suppose if you put n equal to 1, then sin pi by 2 is 1. If you put n equal to 2, then sin pi is 0. So either we get 0 or 1, but the first value cos pi by 2 is always 0. So ultimately the first term is 0, and the second term is integration of cos to the power n minus 1x sin nx into sin x under the limit 0 to pi by 2. So we have in is equal to integration of cos to the power n minus 1x sin nx sin x under the limit 0 to pi by 2. Now let us try to calculate this value. What is the value of sin nx into sin x? Or we can also say that what is sin a into sin b? So we know that cos a minus b is equal to cos a cos b plus sin a sin b. Now here a is equal to nx and b is equal to only x. So let us substitute cos nx minus x. This is nothing but cos nx into cos x plus sin nx into sin x. Let me transpose this to left hand side, or we have to transpose this to left hand side. Then we have the value of sin nx into sin x. This is nothing but cos n minus 1x minus cos nx minus cos x. Now we can substitute the value of sin nx into sin x in the equation number 2. This equation, we have in equal to cos to the power n minus 1x, and this sin nx into sin x is cos n minus 1x minus cos nx into cos x under the limit 0 to pi by 2. Let us open the bracket. If you open the bracket, then it is integration of cos to the power n minus 1x into cos n minus 1x minus cos to the power n minus 1x into cos x. It will become cos to the power nx and cos nx. This one. Now we have what is in. This is what in is equal to integration under the limit 0 to pi by 2 of cos nx cos to the power nx cos nx dx. So this is nothing but in. This is in, and this is what in place of n it is n minus 1. So we can write down this is in minus 1. This is in minus 1. So we can write down in equal to in minus 1 minus in. So therefore, if we transpose this to the left hand side, it will become in plus in is equal to in minus 1. So 2in is equal to in minus 1. Hence, in is equal to 1 upon 2 in minus 1. So this is our first result. This is our first result. Let us again prove the second result. So in the second result now, we have to prove that in equal to pi upon 2 to the power n plus 1. So from equation number 3 or the previous result, what we had already proved, in is equal to 1 upon 2 into in minus 1. So now if we write down what is the value of in minus 1, it is 1 upon 2 in minus 2. Like that, if we replace n by n minus 1, then it will become in minus 1, 1 upon 2 in minus 2. So in minus 1 can be written as 1 upon 2 in minus 2. It can be written as 1 by 2 into 1 by 2 is 1 by 2 whole square into in minus 2. So similarly, we can also write down if we take again in minus 2, which is equal to 1 upon 2 in minus 3. So 1 by 2 whole to the power 3 into in minus 3. So if we multiply, if we do the reduction formula, if we use continuous this reduction formula, then the nth term will be 1 by 2 to the power n and in minus n, and in minus n is nothing but I0, and I0 is what? We know that what is in? In is equal to integration under the limit 0 to pi by 2 of cos to the power nx cos nx dx. So if you put n equal to 0 over here, this is 0 and this is 0. So we have cos to the power 0x into cos 0. Cos 0 is 1 and cos to the power anything has power 0 is again 1. So we have 1 upon 2 to the power n integration of dx or 1x with respect to under the limit 0 to pi by 2, and if we integrate it, what is the integration of this is x under the limit 0 to pi by 2, and if we substitute the limit 1 upon 2 to the power n, this is pi by 2, so this is nothing but pi upon 2 to the power n plus 1. And since this we have to prove it, so this is the desired result. So in this example we have proved both the result, that is in equal to 1 upon 2 in minus 1, and which is equal to pi upon 2 to the power n plus 1. This is the desired result. Thank you.